Section 4.5 talks about solving. We're going to find what x equals. Today we're going to focus on mostly solving exponentials, and then tomorrow we'll work on solving logs, and then we just have a whole bunch of problems that we're going to practice. Because you guys, it's just solving equations. It's not that bad. You just have to remember that to solve an equation, you have to use inverses. You have to undo, right? On your calculators, ln and e are on the same button. They are inverses of each other. So look at your calculators, guys. Where it says log, it also has a 10 to the x, right? Where it says ln, there's also an e to the x. I know I keep saying that. That's really, really important. I'm going to write it down here. All right, so I'm going to write it down. ln and e to the x are inverses of each other. Log and 10 to the x, or exponential, inverses of each other. Inverse means opposite. So when we're solving these problems, I'm not sure why this is crooked, but how do you solve any equation? Use the opposite of PEMDAS, right? You're trying to get x by itself. This is the exact same thing. You're going to see all the steps to solving an equation. There's one pre-cal, like tree kind of step, and that would be the log or natural log undoing on each side, and then that's it. Everything else is basic solving an equation. So let's look at letter A. Okay, I have e to the x equals 72. When I look at this equation, the first thing I do, and you should do as well, is you want to kind of look at your function itself. Is there anything being added, subtracted, multiplied, or divided to that e to the x? No. Right? You don't have to undo anything. So now I look at it and I say, okay, I have e to the x. What is the opposite of e to the x? ln. E and ln are opposites of each other. So in order to get x all by itself, if I take the natural log of this side, what happens to the ln and the e? They cancel out. What you do to one side of your equation, you guys do where? To the other. So you do it on here. So now e and ln cancel, so you have x equals. And in your calculator, guys, give me 3 decimal places. What is the natural log? What's ln of 72? 4.277. All right, 4.277. Now, with these problems, this is the great thing about solving. What can you do with that answer? You can plug it right back in here, and you guys should do this every time. Plug it right back in there. You don't have to write the check out. Just use your calculator. Hit E, so second ln, and then put 4.277. What'd you guys get? 72.02. Are you ever going to get the exact answer?
No.
No, because we're rounding. But you should get something really close. If you don't, then you just did something wrong. Let's look at B. We're just going to solve a bunch of equations today. Let's look at B. B says 3, and then I have 2 to the x equals 42, right? Let's do the same thing we did just a second ago. First thing I'm going to do is just highlight, circle, whatever, my my function. Excuse me. Is there anything being added, subtracted, multiplied, or divided?
No.
Yes.
Yeah.
3.
Right? You see that 3 out in front? I'm going to divide both sides by 3. Yep. So divide both sides by 3. Now I have 2 to the x equals, what's 42 divided by 3? 14. All right? So now my function's by itself. So I look at this and I say, okay, 2 to the x. What's the opposite of an exponential function? Log, right? So I'm going to write the word log right here, but I need this log to have a little number. What do you think that little number is going to be?
2.
Why is it going to be 2?
Because there's a big 2.
Because there's a big 2. Watch, guys. What happens when you have log 2, 2? It cancels out. So what you do to one side, you do where? To the other. So this is log 2, 14. So I have x equals, this is the change of base that we did the other day. How do you put that in your calculator? Log 14 divided by log 2. It's log of the number divided by log of the base. So in your calculator, hit log 14. divided by log 2. 3 decimal places. What'd you guys get?
3.807.
Yep, I got the same thing. X equals 3.807. And I'm going to take 2 seconds, and I'm going to plug it right back in, right there, using my calculator, just to make sure I get something close to 42. So I have 3, 2, and I'm going to raise it to the 3.807 power.
41.9.
Say it again.
Isn't it 2 to 3.80?
Yeah. Did I not say that out loud? That's what I plugged in. I said 3, sorry. So I got 41.9896. Is that real close to 42?
Yeah.
Yes. So you know you're right. Every single time you should check your answers. 1, to make sure you're right, and then 2, when we do logs, you'll need to check for what's called an extraneous solution, something that does not work. All right, let's go over to example 3. Again, if you get into a routine, kind of make a habit out of things, it's not so bad. First thing I'm going to do is highlight my function itself. Is there anything being added, subtracted, multiplied, or divided? It's that e to the 2x. Yeah. I got the minus 3 and the 4, so what can I do? I'm going to add 3 to both sides. Good. So add 3 and divide by 4. So I have 4 e to the 2x equals 5. Divide by 4. Now, you guys can, you could simplify this if you wanted to, because 5 over 4 is a terminating decimal. I would wait till the very end to do any calculations, like any inside your problem. Because the more you round, the further away you get from the answer. Now, I know that I'm going to write something in front of that. That's why I made a space. But is your E now all by itself? Yes. So if you can't remember, look at your calculator. What's on the same button as E? What's on the same button as E? ln. If I take the natural log of this side, what happens to the E and the ln? They cancel out. So what you do to one side, you do to the other. And you just simply put it in your calculator, guys. You have 2x equals. What is the natural log of 5 divided by 4? 0.223. All right. And then what's my next step? I'm going to divide both sides by 2 because I want just x. So x equals, what'd you guys get? 0.112. Okay. Now take 2 seconds, and what are we going to do with this? We're going to plug it right back in there. So just hit in your calculator, hit 4, second ln, and then you have 2 times 0.112, and then minus 3. What'd you guys get? 2.0042. It's pretty close to the whole number 2. Yeah?
Yeah.
Okay, good. Good. Anybody have any questions so far?
Wait,
Sure. Your answer is 0.112. I just took it and plugged it back in. Okay, scooting along. I'm going to do example 4 and example 6. And then we're going to stop for today, and we'll pick it up tomorrow. You guys can start on your website. I want to talk to you about your website. But if I look right here, first thing I'm going to do, just like we've done every single time, is I'm going to highlight just the function. What kind of a function is this? Is this an exponential or is this a log? It's an exponential. It doesn't say the word log, right? All right, so at some point, what's the opposite of exponential? Log, right? At some point, you're going to take the log. But you have to get your function all by itself. So what do I need to do? 2 things. I'm going to add 4 to both sides. Good. So plus 4. So I have 2. I'm going to change this to an x. So 3 to the 2x minus 5 equals 15. Now what? Divide both sides by 2. Now again, you can do 15 divided by 2 in your calculator. It's a terminating decimal. But sometimes you'll get one that's not terminating. It doesn't just end quickly and nicely. So I would leave it. Yeah. So you have 3 to the 2x minus 5 equals 15 over 2. So now that your function's by itself, you have to undo that big base of 3. What's the opposite of a big base of 3? You're going to do log in front and then the little 3. Whatever the big base is, you use that little log so that it cancels out. What you do to one side, guys, you do where? to the other. Good. So log little 3. So 3 log 3 cancels. Your exponent comes down. And then in your calculator, you would do log of 15 over 2 divided by log 3. What do you guys get?
1.834.
Log 15 divided by 2. $1.834?
Yeah.
Okay, so 2x minus 5 equals 1.834. Inside your problem, you should at least have 3 decimal places. You don't want to round that to 1.8 because then you get further and further away from the actual answer. But what do I do here? I'm going to add 5. Good, so plus 5. 2x equals 6.834, right? And then divide by 2. So what does x equal? 3.417. And what can I do with this answer? I'm going to go right up here and plug it right back in. Take 2 seconds and practice doing that. So you have 2, parenthesis 3, and then you raise it to the 2 times 3.417 minus 5 power. Close your parenthesis, and then minus 4. What do you guys get?
10.99.
10.999. That's pretty darn close to 11, right? Yeah. Okay, good. Good. So anytime you start off with an exponential and you go through the process and you solve, you can always just take your x, plug it right back in, just make sure that it works. Now when we come down here, right, I'm just going to do these 2, and then I'll let you guys start on your web assign because some of the problems are kind of lengthy. We're going to work on solving logs tomorrow, but I just want to introduce this to you. If you guys notice, I'm going to rewrite this. I have the natural log 3x equals 2. Now, every time we've done these problems, I've told you to isolate your function, right? So I have the natural log of 3x. Do you notice where that 3 is? Can you divide both sides by 3? No. If there was a 3 out in front, like if the 3 was here, you absolutely could. But if you notice, that 3 is stuck in between the natural log and the x. So you have to just leave it. That is part of the problem. So now I look and I say, okay, well, what's the opposite? Look at your calculator. What is the opposite of ln? E, right? So I'm going to put a big E. I'm going to exaggerate this, but sometimes it's very helpful. I'm going to put a big E, and then everything goes in the exponent. So this goes ln 3x. What you do to one side, guys, you do where? So I'm going to put a big E, and where does the 2 go? To the exponent. Same thing. So on the left-hand side, E and ln cancel out. So you're left with 3x equals, what is E squared? 7 point what? 389. Okay. And then what do? Divide both sides by 3. So x equals 2.463. Now, you can absolutely check this. 1,000% you can check this. In your calculator, you hit ln, and then you have 3 times 2.463. And you hit enter, and what do you get? 1.99999. Pretty darn close to 2. That make sense? All right, one more, and then we're going to be done for today. Letter B. Right, again, what are we starting off with in letter B? Logs. Right? What do you notice about letter B? All right, it has a log little 3. Where? On both sides, right? If you notice right away that there's 1 log on the left-hand side and 1 on the right-hand side, and they have the same little base, you can just cancel them out. Now, sometimes there'll be 2 on one side that you have to smush together and condense. We'll talk about that tomorrow. But if you notice that the left-hand side and the right-hand side have the same exact log with a little base, they just cancel out. The reason why is this. What is the opposite of log? Exponential, right? So what would my big base be in this problem? What would my big base be? If the little log is 3, then the big base would be 3. So watch, you go put a big 3, and then you have log 3, 5x minus 1 equals, what you do to one side, you do to the other. So big 3, and then you get log 3 to the x plus 7. And what happens, guys, with 3 log 3? Cancels and cancels. So you're left with just 5x minus 1 equals x plus 7. Now, if you saw that from the beginning, you could just cross them out, like right here. That's fine. But it's only if there's one on one side and one on the other. So now we go through the motions, and I'm going to add 1 to both sides and subtract x. So 4x equals 8. And x equals 2. Yeah? All right. Something to be careful of. Everybody write down your calculator. What is log of negative 5? Error. What's the natural log of negative 11? Error. What is the log of negative 27? Error. What are you guys noticing?
Negative numbers can go.
You cannot take the log of a negative number. So in these log questions, these are harder to go back and check because you have to do the change of base thing. But what I do caution you to do is plug your x back in just to make sure the log itself doesn't become negative. Because if it does, then you have to cross it out and it becomes an extraneous solution. It's one that doesn't work. So if I go up here, just think for a second. If I plug a 2 in here, what's 5 times 2? 10. 10 minus 1 is 9. Okay, you're good. It's not negative. If I plug a 2 in here, 2 plus 7 is 9. Not negative? You're good. So this is fine. But there will be situations, and we'll do some tomorrow, where you get an answer. You get x equals something, but when you plug it back in, the number in the parenthesis, like this parenthesis, becomes the negative. And then if you were to do that in your calculator, it would tell you error. You guys got that? Okay.